Good morning, my YouTube viewers. In this video, we're going to be covering Spearman's rank correlation test, and we did actually cover Spearman's rank correlation test in a previous video, but we're going to cover it again as a non-parametric test. So what we're going to do is we're going to write a program in Python to prove it. And in order to write the program in Python to prove it, then what we're going to need to do is we're going to need to import some libraries. So the first library that we're going to import is NumPy as NP, which is a numeric library, and it also creates NumPy arrays. And then we're going to need to import Pandas as PD, which is a data processing library, and it also creates data frames and series. We're going to import matplotlib.pyplot as PLT as a visualization library, and from scipy.stats we're going to import Spearman R. And then so scipy is Python's scientific library, and stats is the statistical module within scipy, and Spearman R is the model that we're going to be using to perform a correlation. So what Spearman's rank correlation test does is it checks the strength and direction of monotonic relationship between two variables. So what we want to do is we want to simulate the data for the two variables. And before we simulate the data for the two variables, what we need to do is we need to set our seed. And when you set the seed, every time you run the program, it initializes to the same values. And that's why you set your seed. So you set your seed by typing in np.random.seed, and you can type in any number you want in between the brackets. So we set our x variable as being np.random.uniform, and uniform means it's a uniform distribution, brackets 1, 100, 30. And so, so it's going to make values between 1 and 100. And y equals 2 times x plus np.random.uniform, brackets -20, 20, 30. And then so this y variable is related to the x variable because it has x in it. So now we're going to compute Spearman's rank correlation coefficient, correlation, p-value equals Spearman R, brackets x, y. And then what we're going to do is we're going to print the results. We're going to print the Spearman's rank correlation coefficient and the p-value. So we're going to come down here. Spearman's rank correlation coefficient is 0.976, so that means it is almost a perfect positive correlation, but it has a p-value of 0. So since it has a p-value of 0, that means if there was a hypothesis test, the hypothesis test would not accept the null hypothesis. So now what we're going to do is we're going to create a scatter plot of the two variables. So plt.figure brackets fig size equals 6, 4, plt.scatter brackets x, y, color equals blue, alpha equals 0.7, label equals data points. And then you have your title, your scatter plot of x versus y. And then you've got your x variable being variable x and your y variable being variable y. Your grid has an alpha of 0.7 and you have a legend. So we're going to annotate the Spearman's correlation result on the plot. plt.text brackets 10, max y minus 10. And you're going to print Spearman's correlation. Font size equals 12. Color equals red, PLT type layout, and you're going to show it. So this is the graph that we have made. Spearman's correlation is 0.976, and then you have the data points. And so basically, you should have 30 data points. I haven't counted them, but there should be 30 data points there, because whenever we made the X and the Y variable, it had a sample size of 30. And you can see that the X and the Y variables are very closely correlated to each other. The reason why they're very closely correlated to each other is because the Y variable actually had elements of the X variable in it. But this concludes the video on Spearman's rank correlation coefficient, and the next video we will be discussing another non-parametric test. So I hope that you decide to watch it.